And now let's focus on the risk knowledge portion of the framework, which is understanding the risks. So in our examples that we're going to use today, we're going to focus on flood risk, but this process will apply to any type of a hazard risk. So what is risk knowledge? It's gaining information on, in this case, like the floodplains, what existing floodplain information is available, where are populations, where are the actual people that could be impacted by the flooding, where are there special considerations that you need to take into account. For example, hospitals and schools have special considerations when you're thinking about the people. They may not be at home, they may be at work, they may be, in the case of hospitals, maybe in a hospital bed where equipment is keeping them alive. Roads are an important piece too, because you want to understand how people can get around during the floods and what roads are still open and what roads are closed. You want to have information on evacuation routes, because you want to know whether the flooding or the inundation is going to actually block certain evacuation routes and people have to use other routes to get to places. You want to have information on the drainage areas that you have. You may even do simulations and modeling to predict the impact of, say, some event that you're worried about happening to your area, and you do those simulations and it gives you information. But all that information together is combined into what we call risk knowledge. But there's a structure to it and a way that is used that I want to explain in more detail. So this is probably the most important concept to think about when we're doing this. So vulnerabilities are, what are the things that are going to actually be impacted by the hazard that you're trying to deal with? And that's, vulnerabilities are things like people, buildings, hospitals, schools, roads, infrastructure, your water treatment plant. These are all things that could be negatively impacted by a hazard. So to give you a visual of that, here, the vulnerabilities here are where the people are, where the housing developments, where the buildings, where the roads. So that's the vulnerabilities. The hazards are, where is the flooding going to actually impact? So where's the different levels of inundation going to happen, and where is it worst, and where, and also knowing where it's not going to happen is important, because you don't have to worry about doing the sort of the risk management for places that aren't going to be impacted. You want to focus on the places that will be impacted and that overlay with all of the potential vulnerabilities. So in this example, you can see where we've identified some red areas where there are potential people at risk from flooding, or buildings or infrastructure, but the other places where there's really nothing that's going to be impacted, those are not part of what you care about. So this sort of pictorial view of this is really the most important concept we're trying to get across, which is to have a good understanding of your vulnerabilities and a complete understanding of those, and then understand the hazards and put the two together, and then wherever they intersect, that's where the real risks are potentially happening. So some other things that you want to include in your planning, there are things like, how much warning do you need? Because, and I'll just use an example of hospitals versus schools versus the public. In the case of a school, you may be able to evacuate all the students from a school in half an hour and they all can gather in some safe place around the school. But if you have a hospital that's in the area at risk, the hospital may take hours and hours to evacuate, because the evacuation process in hospitals, you typically have to move people in a way that's safe for them. And if they're sick and they're on special equipment for breathing or life support systems, they have to be moved with all that equipment in place. And so it's complicated. I've seen situations where they evacuate hospitals and they end up just having a relay of moving people with ambulances, and it takes a long time. And so understanding what types of vulnerabilities are in these hazard areas has a big impact, along with understanding how much time they need to do things, because that sort of goes into the emergency action plan, trying to give the time and the warning to the places that need that time. You want to have understanding of the relationship between the catchments and the risks. There's some knowledge that you have to have of where the inundation is going to be and how deep the inundation is going to be, and whether it's just water rising or whether there's actually flows involved where people could get washed away. And then you also want to have information on how fast and how well you can get communication to the public, so that you can figure out a strategy to get them notified and get them to start doing the right things to get out of harm's way. Going back to this concept again, because it's important for this, the intersection of the vulnerabilities and the hazards are where the risk exists. So let's start talking about some of the different types of vulnerabilities that can be out there. As we mentioned before, the main vulnerabilities that are out there are people are one of the biggest vulnerabilities that happen, but buildings, hospitals and schools, roads, and especially people and cars and roads, because in the US, for example, the majority of people that die in floods die in cars. They don't die in their house. They die because they go into water that sort of washes away their vehicles and then they end up drowning. And so roads are a big risk during floods. A different example would be you could have a park that's along a river, and they have these all over the place in the US where people camp along the edge of a river. But if the river is going to flood, then all those people are at risk. So they represent vulnerabilities, and those are the people you want to get out of the way if there's potential for flash flooding coming through to wash out all the campers. And that's another type of thing that happens quite often. So this is a GIS example of looking at the vulnerabilities. So here in this particular example, we're doing a zoom in of an area that's in one of the river basins in Peru. And in the actual map, the color coding is a representation of the population density within that town. So if you look at areas and as you go into the darker and darker colors, that's where there's a higher population density. And this is a representation of the vulnerability of having people that could be impacted by the flooding. So let's go on to hazards now. And what are the kinds of hazards that you would worry about, not just for flooding, but for any type of hazard? So there are a bunch of potential hazards that people can run into. So flooding is the one that we're using as an example in this presentation, but there are hazards from landslides. Landslides are often created because of rainfall. It's the same kind of rainfall that causes flooding can cause landslides or mudslides or debris flows, and those are another type of hazard. Wildfire hazards are another type of hazard that you could apply this same approach that we have in this presentation towards wildfire hazards. Extreme weather hazards is another type. Earthquakes, tsunamis, drought, these are all different types of hazards that have a spatial characteristic where they impact regions or areas, and it can impact them in different ways. And understanding these hazards is important to this, at least to applying this approach. At AEM, we're dealing with a multi-hazard solution. That's our approach to dealing with this problem as we apply this framework, but we're trying to allow the framework to take into account different types of hazards. So when we do analysis, we'll look at things like climate risk, we'll look at wildfire risk, we'll look at meteorological hazard risk, which meteorological includes a lot of things we've talked about: flooding, heat, extreme weather events, storm surge from hurricanes, things like that. We also take into account things like winter weather hazards, icy bridges, icy roads, blizzards, ice dams and rivers that can cause flooding during the wintertime. Those are other types of hazards that we deal with. And geologic hazards are another type. Earthquakes, I think we'll maybe discuss a little bit about earthquakes later on in the presentation, but all type of geological hazards fit into this category. And then hydrologic hazards is the main examples that we're using in this presentation. Is the impact of flooding, but you could look at impact of potential mud flows or erosion when it rains heavy in the Northeast, and erosion erodes the railroad tracks, and then there's a hazard for the trains where they might actually derail because the structural integrity of the tracks that they're on are damaged by the heavy rainfall and runoff. So this map is just sort of some examples of types of hazards that have been mapped into it. This is a national map. This is another Peru example, but in these maps, you can see on the left that the hazards from inundation from flooding are represented, and they have a color coding for where the hazards are the worst, and then color coding for places that go from yellow, orange, yellow to green for places that have less hazard. But this gives you an example of the country that sort of has built a hazard map for this type of hazard so that they can use it for this type of planning. On the right there is the hazards from mass movements, which is the words that we're using for rock slides and landslides. And if you look in this map, you can see that most of the heavy hazard areas are along the Andes Mountains where the terrain is steep. And when they get wet weather, then the rock slides and landslides occur a lot more often. It's actually a major correlated factor to rock slides and landslides happening in Peru. And you can see that red area follows along the mountain ranges there. So risk is the thing that you derive from when you intersect the two. So this is the graphical depiction of it, but this is the most important concept we're trying to get across in this, is that you want to understand your vulnerabilities, and then you want to intersect them with your hazards, and that's where you get the risk information. And for many of the projects that we do, this is the approach we have to identifying areas where we want to put the flood warning systems in, where we want to build the evacuation plans, where we want to basically implement the solution in these areas of risk. So getting back to this example in this one region in Peru, so there's a town here, and we show the populations that are potentially impacted by the flooding. And then this blue area that's in the middle, which shows the river, this is actually a representation of the area that the potential flooding from the river can go out. So this is the maximum extent when we were doing this project in understanding where the impact of the flooding was going to potentially inundate into the towns. And in this example, if you look on the big map on the right, there really isn't a lot of inundation in the rest of this river basin. It's primarily centralized around this area that we've zoomed into. And there's not a lot of population in this area. The population is in the zoomed in area too. So there's really not a lot of other people that are impacted, but in this particular area, we're seeing where the population in this town is directly impacted. So let's talk about some real world examples of using this process and how you would use it. So I'd like to show you a few more detailed examples about Peru. So this is a map where we're essentially looking at the potential inundation in the area, and then this also shows areas where the rainfall rates can be the highest. And so in this map, you can see the coastal plain of Peru, but as you go up into the mountains, the area that's green, those are the places where the rainfall is the heaviest. In Peru, it's interesting, the coastal plain is like a desert, but in the mountains, there's a lot more rainfall. And that rainfall is driving this flooding and inundation. And so this is another map that we've developed of the maximum inundation that we expect from the river flooding. If you take that same example and look at some other factors related to it, you can see where we're showing the populations that are in that area. So you can see based on the color coding, the population densities, which gives you an idea where most of the people live and where all the buildings are at. So the buildings and the people, the roads. And then this particular map, we've also done a sort of a color coding of the potential risk from mass movement. So these are where the rock slides and landslides are most likely to happen. And so the red areas on the right-hand side are the parts of the basin that have the most potential for landslides and debris flows and rock slides. And the areas that are green have the least amount of potential risk. And so it gives us a mapping to understand where the different risks apply. And you can see here, at least for the town of Pura, from rock slides and landslides, the town itself has very little risk from that. So we wouldn't put a system in or even try to design a system to handle that in that area of the country. But there are other small areas on the map that have populations along the river. They're in the areas that have higher risk, that have red and orange in them. There are some populations there, and that's potential areas where you might want to put some systems in place to help deal with that and put monitoring in place and help build evacuation plans for that particular problem. So this is another example that I want to bring up that is looking at it in a really different way, but this is a separate project that we did for Virginia Department of Emergency Management. We're trying to help prioritize the places where they should focus on flood warning in the state of Virginia. So this is a map that shows by county where the population of the people are. So you can see where the most populated counties are and the least populated by this color coding. You can also see within the counties what percentage of the population of those counties fall below the poverty line. And unfortunately, it turns out that the people that are the most vulnerable, so people that are in poverty, have the least amount of things to support their resiliency. Those are the people that are also the most vulnerable to these hazards. So in any case, this is some of the information that we use to create this prioritization. And so then we also looked at the hazards that happen in Virginia. And essentially, we mapped all the floods in the state to the counties that they occurred in, and then showed essentially the numbers of floods and color coded it that way. So you can see some of the counties have a lot of flooding, some of the counties have no flooding at all, and some of the counties have some moderate flooding that happens. And we use that to create a prioritization for the project of where to apply the resources first, where to apply it second, and where to apply it last after everything else is done. And so it gave a way to focus time and resources within the state on the places that have the highest potential hazard with the highest potential vulnerability. And with that, I think that we can answer some questions.
Is there a template for assessing risk for flooding that is, say, a standard practice document for most types of floods?
So we have a standard approach, and the thing that I'd like to say is that in the US, there's a certain set of information available, which at least when you're dealing with flood warning systems in the US, that there is a standard approach and a standard set of available documents. But I would say that something like the FEMA flood maps, for example, they give you knowledge of flooding, but that type of flooding isn't always the type of flooding that occurs. So rain-driven flash flooding is not always covered in those types of FEMA flood maps. Those are more of flooding from large events and riverine flooding, which is a little bit different than all types of flooding. And I would say that the tools that we have available to us cover the majority of the need, but there's still some stuff that has to be done custom when you're dealing with this type of an application, and you have to do some evaluation of whether rain-driven flash flooding is also a problem, and then that typically involves a more sophisticated approach for planning and assessing the potential hazards from that. So that I'll just say that because we see that all the time in the US, where there are places that flood all the time, and those are the areas that tend to be impacted and represented in the FEMA maps. But there's other places where the flooding is unique, but it's occurring because rain-driven flash flooding it's less predictable. But in any case, in the US, most of the tools are there, but there are still some things that have to be done. And you end up wanting to have some engineering support and people that understand rainfall and hydrology to help with that process.
Thank you, James. That's helpful. We've got another one here about assessing risk when your vulnerabilities are statistically changing over time. And I'm going to combine that with another one just to add color. You can tell me if you would interpret it the same way. For example, someone earlier had talked about as you have population being built up, you have more impermeable surfaces changing, so your vulnerabilities change. As that's changing over time, how do you keep up with the risk?
So that fifth principle where you take, first of all, how you did with events and you apply it to improvements. The other part of that, I guess I didn't talk about before, is that you also need to take new information that you get. So let's just say, for example, that a city's added a new subdivision that creates new vulnerabilities, and so that needs to be taken into account into the flood warning system, and it increases the risk areas in those situations. Or as I mentioned, the changing ability for increased runoff from construction and building of roads and parking lots and everything else. Those are all things that do need to be taken into account. And the idea with the vulnerability information is that it's not static, but it's not something that should change very much during an event, but it is something that changes over time, like over weeks and months, because populations move. There's places that happens in Peru a lot that, for example, if it doesn't flood for a while, a bunch of the poor people move into the floodplain and start building little shanty houses in the floodplain. And so they're increasing the risk because they're living in the place where it's going to flood the next time that a bad event happens. And so that has to be taken into account. So it's part of the process to take into account change, and that improvement cycle that we're talking about is the place that you would also look at change.
Oh, that makes sense, James. So here's a question, a follow-up to that. If I'm a flood manager trying to keep up with all these changing vulnerabilities, where's a good place to get information about my vulnerabilities?
Yeah, that's a good question because there's lots of different databases. The problem that I see is that not all data and databases out there have been converted into a nice graphical GIS form that you can use and just put stuff together easily. But there are lots of sources. The concept of a census isn't just in the US, like knowing where the populations and the density of populations are. That concept is used all over the world, and they try to collect that information so that you have some sense of where the people are. So that's one type of vulnerability. The buildings and the roads, those are changing all the time. What we're doing, so in the case of the Peru project, there's a separate project to do soil stabilization work around all the rivers. And so right now we're designing a flood warning solution without that work having been done yet. And so the risks are going to change once they do all the soil stabilization work. And so we're going to have to recalibrate our models around all the changes that they do so that we can deal with that change.